Hi, this is Stan Lyle with Master Math. During the lesson, you're going to come to some You Try It slides where you're asked to do problems that relate to the lesson. Hit your pause button, try the problem, and then hit the forward key to move on to the answer. I hope you have a really good time today. Today we're going to talk about solving quadratic equations by graphing them. And we're going to use some concepts that you're already familiar with. For instance, we're going to use roots. We're going to use the zeros of a function. And we're going to introduce something new. We're going to introduce a quadratic equation in intercept form. Here's a quadratic equation, and we've learned one way to solve it. We could factor this equation to find the roots or the solution to this problem. And if we factored it, we determined that it equaled x minus 4 times x minus 1. And we'd remember the zero products property, which would tell us that either x minus 4 had to equal 0, or x minus 1 had to equal 0. So then we know two potential solutions. We know that either x equaled 4 or x equaled 1. And those would be our solutions, our roots, or our zeros. Well, now let's graph this quadratic and see what it looks like. Let's get the axis of symmetry first. X equals minus b divided by 2a. Our b is minus 5. It's not positive 5, it's minus 5. And our a is positive 1. So we'll substitute minus 5 for b and positive 1 for a into x equals minus b divided by 2a, and we'll get x equals 5, positive 5, over 2, or x equals 2.5. And that's our axis of symmetry. Now let's calculate our vertex. We'll put 2.5 into our quadratic, x squared minus 5x plus 4, and calculate what y is when x is 2.5. And it turns out that's minus 2.25, minus 2.25. So we'll put a dot on the graph right about there. Now, we know this opens upward because our a value is positive 1. But we're going to see that it opens upward because we're going to come up with our y-intercept at this point. Our c value is positive 4. So we cross the y-axis at positive 4. And we'll put a dot right there. And we know that there's a mirror spot on to the right of the axis of symmetry. That's 2.25 units or 2.5 units to the right of the axis of symmetry. So we'll put a dot right there. And that gives us 3 dots, and we can plot a curve from those 3 dots. And it'd look just like this. And here's some interesting stuff. You can see that this curve crosses the x-axis at 2 points. It crosses it at 1, and it crosses it at 4. It crosses right here at 1 and right here at 4. And guess what? Those are the solutions we came up with when we factored the equation. So another way to solve this equation would have been to graph it and figure out where it crosses the x-axis. And that would tell us what our solutions or our roots or our zeros were. Well, now it's time for you to try one. Find the roots of this quadratic by graphing. X squared minus 2x equals 3. If you're going to solve this by graphing, you need some graph paper. So go get some. And if you don't have any handy, you can go to my website, www.mastermath.info, and go to the worksheets page, and you'll see a link that will open up a piece of graph paper, and you can print that. Well, go ahead and hit your pause button, solve this problem, and then hit your forward key to move on to my solution. we're going to need to graph x squared minus 2x equals 3. But I can see that's not in standard form. My 3 is on the wrong side of that equal sign. So I'm going to shift this around to put it in standard form. And it's going to rewrite this way. X squared minus 2x minus 3 equals 0. Now I can figure out my axis of symmetry. X equals minus b over 2a. And that turns out to be 1. So I'll plot my axis of symmetry on the graph. Now I'm going to calculate what my vertex is by substituting that 1, that x value at the axis of symmetry, into the original equation. And when I do that, I get y equals minus 4. At the axis of symmetry, the y value is minus 4. So I can plot my vertex at 1 minus 4. Now I know where my y-intercept is. My c value up here is minus 3. So I cross the y-axis at minus 3. And I've got to have a mirror point for that minus 3 value on the other side of the axis of symmetry. Well, I've got 3 points, and I could probably try to graph it from those 3 points, but I think I'd feel more comfortable if I put in another point. And I'm going to pick a point that's a little bit to the right of that value, maybe go out to 4. Let's find out what y is when x equals 4. So we'll substitute 4 into the original equation. And when we do our calculations, we discover that y equals 5. So we'll put a point up there at x equals 4, y equals 5. And then we'll create the mirror point on the other side of the axis of symmetry. 1, 2, 3 to the right of the axis of symmetry with that point. So I'm going to go 1, 2, 3 to the left of the axis of symmetry and put a point there. Now I can draw a graph that connects those points and feel fairly comfortable that that's what the parabola looks like. And I can see from that parabola that it crosses the x-axis at 2 locations. It crosses the x-axis at 0, 3 and at 0, minus 1. So my roots are minus 1 and 3. You remember the first way we learned to solve a quadratic was to factor it. We discovered that if we converted the quadratic to a form such as this, x minus p times x minus q, then we know what the roots were. The roots would be p and q. Well, for x squared minus 2x minus 3 equals 0, we just determined by graphing that the roots were minus 1 and 3. And we can substitute minus 1 in for p, and we can substitute 3 for q, and write the expression x plus 1 times x minus 3 equals x squared minus 2x minus 3. The last quadratic we looked at had 2 solutions. But not every quadratic has 2 solutions. Let's look at this one. X plus 2 times x plus 2 equals 0. The zero products property tells us that x plus 2 has to equal 0 or x plus 2 has to equal 0. Well, I just kind of repeated myself, and I know that x plus 2 equals 0 and x equals minus 2. There's only one solution. And if we were to graph that off of the expanded equation x squared plus 4x plus 4 equals 0, the graph would look just like that. And you'll notice it crosses the x-axis in only one point, minus 2. There's only one solution. And sometimes there are no solutions. For instance, if we were to graph x squared plus 6x plus 10, it'd look just like that. And you'll see that the graph doesn't touch the x-axis. There are no solutions to x squared plus 6x plus 10 equals 0. Now you remember we can factor quadratic expressions and determine the roots, or the zeros, or the solutions. And when we do that, we're really putting them in intercept form. Quadratic equations in intercept form look like this. Y equals some coefficient a, which may be 1, but it can't be 0, times x minus p times x minus q. And when we graphed the equation y equals a times x minus p times x minus q, we discovered that there were 2 points where the graph crossed the x-axis. P0 and Q0. P and Q are the roots of the equation. P and Q are the x values when the graph crosses the x-axis. Here's an example. Let's say y equaled 2x squared plus 4x minus 16. Let's try to put that in intercept form. Now I can see I can factor out a coefficient. I do in this case have an a value because I can take a 2 out of each of the coefficients of this equation and rewrite it as 2 times x squared plus 2x minus 8. And I can factor x squared plus 2x minus 8. That equals x minus 2 times x plus 4. So my original equation, 2x squared plus 4x minus 16, can be rewritten in intercept form, and it reads y equals 2 times x minus 2 times x plus 4. And my intercepts are going to be P and Q. P and Q. But in the basic form, it's x minus P and x minus Q. So if I've got a minus sign here, then 2 is in fact, positive 2 is in fact a root. But if I got a plus sign here instead of a minus sign, then this Q value has to be negative 4. So my roots are going to be positive 2 and negative 4. Now I could graph this pretty easily. I know that my axis of symmetry has to be halfway in between those 2 points. It has to be halfway in between P and Q on the x-axis. So I go 1, 2, 3, and I'm in the middle because that's 1, 2, 3 from each of those points to the middle. And I could draw my axis of symmetry. The axis of symmetry is x equals minus 1. And if I substituted minus 1 into the original equation, I'd get y equals minus 18. So my vertex is all the way down there at minus 18. And now I can probably graph this equation. And it'd look just like that. Try this one. Hit the pause button, do the problem, and then hit your forward key. Okay, I want to see if I can put this equation in intercept form. Y equals 3x squared plus 27x plus 54. And the first thing I see is that I can factor out an a value. I can factor out 3 from each of the coefficients. And then it would read 3 times x squared plus 9x plus 18. Now, can I factor x squared plus 9x plus 18? Yeah, I can. It equals x plus 3 times x plus 6. And my 3 is still there. So y equals 3 times x plus 3 times x plus 6. Well, now can I figure out what my roots are, what my zeros are, what my p and q values are? Sure. My zeros are minus 3 and minus 6. Well, that's our lesson on solving quadratic equations by graphing. I hope you learned a lot, and I hope you had a pretty good time. Now it's time to test your skills. Go to www.mastermath.info, and you'll find worksheets and quizzes there to help make sure you understand this concept. Well, come back and see us again real soon, will you?